Assalamualaikum and hello to everyone. So we are from Group 5. We present about the question that are given for the simplex methods. So the we are from Group 5 consists of three members. There is me, Muhammad IKRAM AFIQ, VICKNESWARAN and Ahmad Nubli. So next, the problem that are given in the example is to minimize the z equal to 2x1 plus 3x2. With constraint to x1 plus x2 equal to greater than and equal to 4, to x1 plus 3x2 greater than 9, x1 greater than 0 and x2 greater than 0. So for the solution, the problem given there is a z equal to x1 plus 3x2. So with the constraint to x1 plus x2 greater than 4 and to x1 plus 3x2 greater than 9. So for the first step to convert the uh, for the first step we need to convert to maximize to the minimize to maximize. So firstly, we need to transpose the metric of the z. So I will pass to the Winneshwaran the solution to the maximize it.
Okay, thank you, Ikram. So as Ikram said, we can see at the top right of the slide the new equation that we have derived from the transposed Z matrices, which is the maximize equation and also both of the constraint equations as well. So using that, we will convert this equation into the matrix that we can see below, which consists of y1, y2, x1, x2, and also z. The first constraint, which is y1 plus 2y2 uh, lesser than and equals to 2, will have value for x1. And for the second constraint, which is y1 plus 3y2 lesser than and equals to 3, will have value for the x2. So that is why in the matrices below, uh, the first row, we will put 1 at the column which consists of x1. And for the second row, we will put 1 to the column which consists of x2. And the last column represents the maximization equation. So for that, we will put the one value at the z part. And from here on, we have to find the ratio of the uh, smallest number. So from the matrices, in the third row, we can see that the -9 is the smallest number. So we will choose that row. And the next step is to find the ratio. So the ratio can be found by taking the uh, right side value of the matrices, which is 2. So this 2 is divided by the 2, and we will get 1. And for the second row, we will choose 3, and the 3 will be divided with 3, and it will be equals to 1 as well. The division of the value can be is selected from the rows that we have chosen. So since we have already find the ratio, we can see that the ratio is 1, 1, and 0. Since the ratio is 1, 1, we will choose the smallest number with the smallest value. So in this case, which we will choose the row 2. So since we have chosen that, the y2 value of 2 will be selected, and we will have to uh, do the ERO, which is elementary row operation, to proceed to the next step. So the step here is to make the 2 over here, which is at the row 1 and column 2, to become number 1. So in order for us to do that, we will derive the equation as the row 1, we will multiply it with 1 over 2, so that we can change the number 2 to number 1. So after we have done the changes, we can see the matrices that we will get at the bottom right of the slide. So this is the slide that we will this is the matrices that we will have to proceed to the next step. Nextly, I will pass to Ahmad Nubli to proceed with the calculation.
Okay, thank you, Vickneswaran. So we will proceed with Vickneswaran said just now, for the coefficient of the y2 at the row 1, we must make it as a coefficient of 1. And then continue for the row 2, we need to eliminate the coefficient of y2 for row 3 and row 2. So by that, R2, in order to diminish the coefficient of y2, we need to use the equation 3R1 minus by R2. And for row 3, we need to use equation R3 plus 9R1. After substitutes the equation, we will get the z value for the row 3 is 9 when the s1 is equal to 9 over 2 and s2 is equal to 0, meaning that in order to get a minimize, because the question asks us to minimize the equation, z is the value that will show that we has get the minimized equation by using x1 with 9 over 2 value and so s2 with 0 value. I think that's it for our group. Thank you.
Thank you.
Okay,